Sources of energy. Lecture number 2. So coming to the introductory part of this particular lecture. In this lecture we will be dealing with the non-conventional sources of energy, the chapter summary of both lecture number 1 and lecture number 2. Okay. So let's start with the non-conventional source of energy. These are just opposite to the conventional source of energy, and hence these are renewable sources of energy. They won't get depleted. Okay. These are hence available all the time. So some of the examples of a non-conventional source of energy are the solar energy, the wind energy, which has been already discussed in lecture number 1, the tidal energy, the wave energy, geothermal energy, nuclear energy. Okay. So let's start discussing about each of these types of energy in detail. Okay. There are actually many more types of energy, but we are going to discuss only about a few here. So now let's go a bit in detail of these types of energy. Note that the net goal of all of these is the same, to generate energy. Okay? But how are all these different from each other? We'll be learning about that soon. So first let's start with the solar energy. This is the most reliable form of energy. The reason because it's available anywhere and any time. Yeah. So the problem with the solar energy is it's not that efficient. I mean, you cannot generate a very high amount of energy. And the equipment for the capturing of solar energy is very expensive. The basic principle which it uses is it captures the light energy to generate electricity. Okay? A classical example will be shown soon. So given below is an example of a solar cell plate. So these blue ones are the solar plates which will be capturing the light energy from the sun. Okay, I hope this is clear. So let us learn about the working of the solar cell. The principal use here is the photoelectric effect. So here light is incident on a photoelectric plate. It excites the electrons and generates the electricity as shown in the diagram below. Now let's study about the wind energy. As the name suggests, here we'll be using wind to generate the electricity. Here a very high speed wind will be developed, a force that could rotate the fans of the windmill. So this rotation will be linked with the dynamo, which will in turn generate electricity. Okay? So given below is a diagram of a windmill. I think you must have seen it somewhere in some part of your life once. So this image shows you the internal part of the windmill, where you have a lot of gears which will be rotating each other to generate electricity. Now let's learn about the tidal energy. So as the name suggests, here we will be using the tidal effects of the moon on the seas. We often come across high and low tides, right? So if we use a dam equipped with a hydro power plant, we can develop electricity from that. It's just as simple as that. Okay? So let's see how can this be done. So given below is again a diagram illustrating the same. These mills will be rotating on basis of the tidal effects by the moon. Okay, hence we can generate electricity. Now let's study about the wave energy. Okay, so as the name suggests, here we'll be using the kinetic energy of the waves. So we can use this technique with a place where there are heavily gushing waters. So this method is quite similar to the tidal energy one. This is actually much simpler than the tidal energy setup. Okay, so here again there's a diagram of how this can be done. So please have a look at the diagram. So this is a wave energy generator. So this one is the internal part of it. Now let's study about the geothermal energy. As the name suggests, this uses the heat energy from the earth's crust. Okay, and we can use this techniques where there are places equipped with hot springs. So when the steam is released from a hot spring, it can be directed to a turbine with the help of pipes, and hence the steam will help in rotating the generator. Okay, this is similar to a thermal plant. So a diagram has been given below. So this is a steam releasing hot spring, and this steam is directed through the turbine with the help of a pipe, and hence we can generate electricity from it. Now let's discuss about nuclear energy. So this method is based on the principle of nuclear fission. Okay, so what is nuclear fission? The nucleus of a heavy atom, when bombarded with low energy neutrons, they split apart into lighter nuclei. Okay, when this process happens, tremendous amount of energy is released. The released energy can be used to produce steam and to generate electricity. Okay, this is a very efficient, but it's highly dangerous. Okay, so given below is a diagram of the nuclear plant setup. Okay, so this is your second diagram. So this is just a schematic diagram of what actually happens. Pause the video accordingly and please have a look. And this is a real time diagram. This is how the nuclear plant actually looks. The diagram, please. Okay, you must have seen this, right? Somewhere in the TV or anywhere else. So these are actually the nuclear plants. So we are done with the diagrammatic part of the nuclear energy. Now, as I have told you in lecture number 1, why are we using only electric energy? Why not some other type of energy? The reason is, only electrical energy can be transferred over very long distances, and it's easy to store and maintain. Okay. Moreover, it's very economical. So, coming to the summary of this lecture. So, I request the reader to read it on his own and pause the video accordingly. Fine. So, this is a very crisp and short summary of the entire lecture. Lecture number 1 and 2. Fine. Fine. So this is the end of the lecture. Thank you for watching.